Good morning, folks, and welcome to Minerals, Rocks, and Fossils Talks. I'm your geology teacher, Jen, and I cannot believe it's already December, but that means we are moving on from mineralogy to geology, and this month is all about plate tectonics. So what is plate tectonics? It is a scientific theory that Earth's lithosphere is broken up into plates, kind of like giant puzzle pieces that have been slowly moving across the asthenosphere. So here's kind of a map of our plates. But how do we know that they're moving? Well, earthquakes and volcanoes are a pretty big clue, but there's a lot more involved than just that, and we'll discuss those in later posts. Now, earthquakes and volcanoes happen in very specific areas, mostly plate boundaries. So let's take a look at our plate boundaries. First, we have divergent plate boundaries. And as suggested by the name, divergent plate boundaries are where plates diverge or pull away from each other. As they do this, hot magma is pulled to the surface because it is less dense than the colder crustal rocks. And we all know heat rises. A good example of a divergent plate boundary is the Mid-Atlantic Ridge, which Iceland happens to sit on top of. That's why it keeps erupting. In fact, here is a photo that NASA took 3 days ago of the most current Icelandic eruption. And it's right on that plate boundary. Now, divergent plate boundaries are not the only places where volcanoes happen to appear. There's another kind of plate boundary, a convergent plate boundary, specifically a subduction zone, where volcanoes will also happen. Convergent plate boundaries, as the name suggests, is where plates converge or come together. There are two kinds of convergent plate boundaries. One type where dense oceanic plate collides with a buoyant continental plate, or two oceanic plates. One happens to be more dense than the other. Either way, one of them is going to sit higher up in the mantle, usually a continental plate, and it's going to go up and over our oceanic plate. This is called subduction. As the oceanic plate sinks into the mantle below, it gets heated up and melted. And as we've already discussed, heat rises, and that heat becomes, that molten hot rock forms volcanoes. In the simplest sense. There's a bunch of other things that goes into this, but for basic understanding, that's how these volcanoes are formed. The Pacific Ring of Fire is a huge example of this. And as you can see, it doesn't go along the entire Pacific, but it does go along most of it. Famous volcanoes in that Ring of Fire include Mount St. Helens in the Cascades, Krakatoa in Indonesia, and Mount Tambora, also of Indonesia, which currently holds the record for the largest eruption in recorded human history, where it caused a mini ice age in the early 1800s. Pretty big problem for those people. The second type of convergent plate boundary is when two continents collide, as in the case of the Eurasian and Indian plates. In this case, when they collide, they crumple and they form huge mountain ranges like the Himalayas or the Alps in Europe. As you can imagine, earthquakes are fairly common along these collision boundaries. It makes sense. If you're going to collide, there's going to be feedback from that. The last type of plate boundary is a transform plate boundary. This is where two plates slide past each other and cause a bunch of friction, which translates to earthquakes. California is probably the most famous transform boundary. in the form of the San Andreas Fault. And lots of earthquakes happen in California. Other often transformed faults will happen along divergent plate boundaries, like the Mid-Atlantic Ridge here. They're going to be perpendicular to those divergent boundaries, and it's where rocks are breaking under stress. So as you can see, there's lots and lots of transform faults along this divergent plate boundary. The rocks are not happy about being pulled apart. Now, if you like what you see here and you want to go into more depth, you can check out my Patreon. I have many Geology 101 lessons posted there because, let's face it, not all of us have time to sit in a 50-minute lecture and learn anything, really. We have lives to live, jobs to go to. But if you have 5 minutes to spare at your lunch break, you could do a little lesson, and some of them involve plate tectonics. So you can go check out other things there as well. If you're not into the lessons, there will be interviews and discussions with my colleagues that'll be posted there as well, including some in-depth takes on some of the Fossil Friday specimens that I've talked about. And if you're still looking for that perfect Christmas gift, I have paleo art for sale as well. So make sure you check out Patreon, and I will fossilise you later.